This is a little review over the 4 transformations that we used when we were graphing trig functions. So the first one we did was, of course, the amplitude change. This one was the easy one. So like if I had y equals 1/3 cosine x, that means I know that the range of the function would be changing. Oops. So I know that my x-axis is not going to change. All right, it's going to stay pi halves, pi, 3 pi halves, and 2 pi. So I'm going to label that. What's going to change is normally our graph would go up to 1 and then down to -1. But since I have an amplitude change on this one of 1/3, I know that I only need to go up to 1/3 and then down to -1/3. So I'm going to zoom in a little bit on this one, help me graph it more accurately. This is the cosine function, so that means my y-intercept is going to be here at 1/3 and then down at 0 and then down to -1/3, back up to 0, and +1/3. So remember the amplitude change, that was a vertical stretch or compression. Of course, this one is obviously a compression. Amplitude change just changes the y-axis. The next one that we learned was the vertical shift. The vertical shift is when you're adding or subtracting to the function itself. So this time, whenever I go to draw my graph again, our x coordinates are not going to change any. But I can see that it is being shifted up too, so I'm going to make sure and do my graph a little bit taller on the y-axis. Again, I know that my pi halves, pi, 3 pi halves, and 2 pi are not going to change since this is simply a vertical shift. So the whole graph is moving up too, but since I know this is a normal sine wave, that the amplitude is still 1, so I actually need to go up 1 more. If you remember in class, what I like to do is I would grab my highlighter and I'll put myself a line right there so that visually that helps me out a little bit. All right, sine will start in the middle, so now the middle of the graph is here at 2. It's going to go up 1 to 3, back to the middle, then down to 1, and then back up to the middle. Again, our amplitude didn't change, it stayed 1, so that's why I just went up 1 and down 1, and that was a vertical shift. Then we had the period change. Let's do cosine of 4x. Okay, so I know it's a period change because I'm multiplying my x value times a number instead of the number being in the front like the amplitude. Remember, if we want to actually find our period, we're going to do 2 pi divided by that number. In this case, that would be 4. So my period is 1/2. So this means this is a horizontal compression. It's getting smaller. If I want to figure out what I'm counting by, I'm going to take my intervals, and then I'm going to, for my intervals, I'm going to take that and divide it by 4. So pi halves, I'm finding 1/4 of, so really I'm counting by 8ths here. So in total length, it would be pi halves, and I'm counting by 8ths. So whenever I go to do my graph, again, vertically that's not going to change any, but it's the horizontal that's going to change here. I remember we talked about how in class, how I'm technically not drawing this to scale, so I'm going to go up to 1 and down to -1, because I know that it's still going to start, since this is cosine, it's going to start up at 1, and I'm still going to have my 4 intervals, but obviously they're going to be labeled differently. If we compared it to the full 2 pi, that graph, of course, would be much, much larger. So remember, when you find your intervals, that this is actually your starting point, that pi eighths. So I'm starting with 1/8, And then the next one would be 2/8. Of course, 2/8 reduces to pi/4. And then 3/8. And then, of course, 4/8 is 1/2, pi/2. And, of course, we know that's where we needed to end up. Okay, so this is the cosine function, so we know that it's going to start up at 1 and then go to the middle, down to -1, back to the middle, and back up to 1. So the way I have it drawn, of course, again, it's not to scale. I know that if I were to compare this with the actual cosine wave, this would be much smaller horizontally because, you know, normally it goes to 2 pi. But that is the period change. And then finally we have the phase shift. Phase shift, let's do minus pi, is whenever we're adding or subtracting, that is a minus sign, inside, like to the x value instead of the whole function. So this is a left or right movement. Of course, this one is going to be a right movement pi, because it's opposite, right? Plus is left, minus is right. Horizontal stuff's always backwards. So just like the last one, my vertical axis is not going to change. Excuse me. But my horizontal axis obviously is. Now, since the only thing that's changing is it's just the graph is moving right pi, I'm still counting by halves like I normally do. So I'm going to go ahead and put my 1, 0, -1 on here. So I would still want to go ahead and put my pi halves there, because I don't want to skip it, and I would like for it to continue to look nice. But it's actually going to start at pi, right? So whenever I'm counting 3 pi halves, 2 pi, I actually need to go one more, right? Because I'm moving it over. Actually, no, I need to move it 2 more. 1, 2, 3, yeah, I need one more after that. 3 pi, there we go. If it helps, just like last time with the vertical shift, like I like to put myself like a little highlighter mark right here. And you don't have to do that. That's just, it helps me. That just tells my mind that my y-axis is now shifted over pi units, in this case to the right. This is the sine function, so that means that it will be starting at 0, and then it's going to go up to 1, back to the middle, down to -1, and back to the middle. So it's the same size, as it wasn't stretched or compressed, it was just moved over, and that was the phase shift. Hope that helps.